Good morning, ladies and gentlemen. What we're looking at in this video is applications of calculus using logs. So we're going to look at a whole series of things we've seen before, like optimization, maximization, minimization, etc., increasing, decreasing functions, kinematics, etc. So everything we've seen before in calculus applies again here, and whatever worked previously will work again here, but now we're just using our ability to differentiate and integrate log functions and exponential functions more effectively. So, take a second to read this question, and you might be thinking, after you've read it, that this is a very odd looking function, t ln t. So if it's odd and you're not sure what it looks like, graph it, and what you should see is this sort of graph here. And what that is saying is that there's some minimum here, and it comes out to be about 0.37 or 36 there. And that age, according to this psychologist, is the age at which children have the lowest memorizing ability. Years. Alright, now that is the answer for this, for A. But we would like to do this algebraically as well. So doing this algebraically involves finding A dash t. Now A dash t is not too bad. This is a product rule. T ln t. So we're thinking U, V. T ln t. U dash equals 1. V dash equals 1 on t. Now U dash V plus U V dash. There's some neat stuff that happens here. U dash V looks like, well, 1 plus ln t. So that's just, 1 times ln t, so ln t plus t times 1 on t. T times 1 on t is just 1. So this entire thing is ln t plus 1. And now we want to solve when it's equal to 0, because 0 is where we find our minimum and maximum. So to find our 0, we have 0 equals ln t plus 1. Follow it through with the calculator with some algebra. Subtract 1 from both sides equals ln t. If you want to get rid of an ln, the opposite to ln is raising things to the base it is. It is base e, so we raise things to base e. They go. And what we're left with is e to the negative 1 equals t, or t equals 1 on e. And if you put 1 on e in the calculator, it comes out to be that 0.37 years. Alright, next question. Manufacturer of kettles is doing a cost minimization study. We want to find this such that the minimum production of 10 kettles per day. Alright, so once again, we need to find the first derivative, c dash of x. Now, the first derivative of 4 ln x is 4 on x, because ln x derives to 1 on x times 4, 1 on x. This here is relatively brutal. This one, you could probably expand and simplify, and that would work out quite nicely. Or you can think of this inside portion as 3 minus x on 10 squared, because you can attribute the 10 to both. 30 divided by 10 is 3, minus x divided by 10 is minus x on 10. And then, doing the derivative of this, you bring the 2 down, so it becomes 2 bracket 3 minus x on 10 multiplied by the derivative of the inner. Now, derivative of the inner is derivative of this inside portion. This bit here, minus x on 10, is really minus 1 on 10x. So its derivative is minus 1 on 10. So this is multiplied by minus 1 on 10, giving that as the derivative of this. Now we are going to want to simplify it. So 2 times minus 1 on 10 is 1 on 5. And there's a negative there, so it's minus 1 on 5 bracket 3 take x on 10, and there's no power anymore because the square disappeared. Alright, let's continue this going a little further to expand and simplify. And remembering, we want this then to equal to 0. So 4 on x take 3 on 5 plus x on, now 5 times 10 is 50. Okay, so far so good. let's look at how this might go out. To solve this, we could put in our calculator into solver, and we get one answer which might not necessarily be the best one. So let's try and get all the algebraic answers. And one way to do this is multiply through by x. 0 equals 4, take 3x on 5, plus x squared on 50. Now, basically we're going to keep knocking off these denominators because they're ugly things. I'm going to multiply everything by 50. So 0 equals 200 minus, if that's multiplied by 50, it'll become 30x plus x squared. And the way we typically see this, because the quadratic is x squared, take 30x plus 200. And now we're thinking for things that add to minus 30, multiply to 200, remembering our quadratics. And if we do a bit of thinking there, we're thinking, well, that could easily be x take 10, x take 20. Therefore, the number of kettles produced is either 10 or 20. But bear in mind at the start, they told us that minimum capacity is 10 kettles a day, so we want to exceed the minimum. That's not possible. Our solution is x equals 20. And note, if at this step we put that into solver in our calculator, I haven't tried this, but I'm pretty sure it will tell us x equals 10, and we'd be stuck there thinking, well, that's a bit unfortunate. So if you're ever seeing a whole pile of fractions, multiply through by the denominator nice and patiently, eventually it can drop out reasonably nicely. Alright, continuing on. Use the integral of ln y dy is equal to y ln y take y plus c to find the exact area bounded by y equals e to the x, the x-axis, the y-axis, and the lines y equals 2 and y equals 3. Now visualizing that is very difficult, so chuck it in a calculator. This is the line e to the x, 2 and 3. Draw. E to the x is that one. 2, 3, and the y-axis, we're being asked to find this area here. Now, that is not easy, simply because we're used to finding the integral, the area under the integral between something in the x-axis. Good news for us is, if we're aware of the properties of logs, we can use ln x, where's my x, and graph that. And what I'm hoping you're able to see, even though the scale on the calculator isn't perfect, is that the area between 2 and 3 on the y-axis and the e to the x is exactly the same as the area between 2 and 3 on the x-axis with ln of x. So what we're really asked to do here, in a very complicated way, is to find the integral between 2 and 3 of ln x dx, which is neat. So when you're finding the area between something and the y-axis, you can use its inverse and adjust the values to the x values, because what you're really happening is finding that one there. Alright, I hope that makes some sense. And I won't follow this through fully because the maths does work out quite easy, because we know in the question that the integral of ln x is that. So this then becomes x ln x minus x between 2 and 3, and we need to go through exactly, so it would need to be an exact calculation. But you guys can do that in your own time. Remember, you're doing the top, take the bottom, so it will look like 3 ln 3 take 3 take, use brackets here, 2 ln 2 take 2. That was meant to be a 2 there. Ooh. Alright. Last one. The particle is initially at the origin and is stationary. Alright, so you're already thinking kinematics, and we're given our initial condition. It accelerates, so we know we're dealing with an acceleration function, given this. The velocity is to find Vt equals a dash t. Alright, so we need to find the derivative of this. I would remember that a of t is really minus t plus 1 to the minus 2, and therefore, apologies, a dash t is going to be positive 2, as the negative 2 comes down and combines with that, t plus 1 to the negative 1. Whoa. Apologies, ignore that. In fact, ignore that entire explanation. I've gone completely the wrong way. Starting this one again, the integral of at dt is equal to vt. Make sure you're going the right way. Differentiating goes from displacement, velocity, acceleration, so you got to integrate going back. It's easy enough to do, the mistake. Alright, so we need to integrate this. Integrating this is not too bad. We know that it's come from a minus, still thinking of at like minus 1 lot of t plus 1 to the minus 2. We know that's come from a t plus 1 to the minus 1, and when it does that, it will throw out a negative 1, which combines with this, so we actually don't need to put anything out here to correct that, and that will have a plus c. So our integral of this would be vt is equal to 1 on t plus 1 plus c, and we're told the initial condition is that it is stationary. So we know that the initial condition is when t equals 0, you have 1 on, well, 0 plus 1 is 1, plus c, therefore c equals 0. Therefore the velocity, at least initially, is 1 on t plus 1 plus, not having a good day today, negative 1, minus 1. C is minus 1, because you take the 1 away. Alright, then we want to integrate this again to find the displacement function. So integrating again to define the displacement function, the integral of 1 on a function is, so if we're integrating this, is going to be ln t plus 1 minus t, because the 1 has come from a t, plus c. And now we need to find c, so 0 the whole way through, ln of 1 minus 0 plus c, therefore c is equal to, and here's the interesting thing, recall ln 1 is always equal to 0, so c is actually equal to 0 this time, so therefore our displacement function is equal to ln t plus 1 minus t plus nothing. And that's our final answer. Apologise, it was a long video, and we'll keep doing more and more practice in class, but keep referring back to your old calculus notes as well, because the same processes apply here, now we're just using logs. Thank you very much.